other side of the world, actually. Hi, everybody. Listen, you can email me. I love to get email. Doing my best to answer that which I can. And so if you don't get an answer, I'm really sorry, but I'm doing my best. The way to get to me is artbell@mindspring.com. That's ARTBELL. Very simple, Artbell at Mindspring, MINDSPRING.com. Love to get emails, and you can fire one across the world. Speed of light. My guest is Dr. Michio Kaku. Dr. Kaku has a new TV show. It's Sci-Fi Science on the Science Channel. It's every Tuesday night at 10 p.m. So if you're, intrigued, and how could you not be by the kinds of things you're hearing right now, you can not only hear them, but I guess see them graphically illustrated on Tuesday night. So that's something you're going to definitely want to check into. So a scandal. In a moment, we're going to find out what the professor's done. New scandal. We'll be right back. By the way, you can also, of course, fast blast me. If you go to the coasttocoastam.com website, you can fire me off a question for Dr. Kaku, and I've got a couple here. Jack in Niagara Falls sends this regarding the emails. Hey, Art, don't let him get away with that. He sloughed off your question about the emails. He dodged. Make him answer. Professor, it was a big scandal about the emails, the global warming emails. Any comments on it?
Yeah, we have an even bigger scandal now brewing. Let me mention both scandals. The first scandal was when somebody hacked into the computer system of a research institute in the United Kingdom, and you had, thousands of pages of sloppy emails. There's no other word for it. There was no smoking gun. No one is accusing people of making up numbers. But, a lot of pettiness came out. Jealousies, turf mentality. We're human beings, and we do all the crazy stuff that any other group of human beings does. However, the second scandal is worse. It's really worse. It turns out there's one paragraph out of 800 pages signed off by over 1,000 scientists, one paragraph with 5 factual mistakes in it. This is a smoking gun of sorts, a small smoking gun. But, for example, it says that by the year 2035, we could see, tremendous melting of the Himalayan glaciers. Well, the scientists in the Himalayas don't think so. They redid the calculation and found out it was a misprint. It should have been 2035. It should have been 2350. So they got the numbers wrong. They interchanged 2 digits. And the report went on, made 5 mistakes in one paragraph. It said the Himalayan mountain glaciers are receding much faster than average. No, they're receding at the same rate as all the other glaciers on the planet Earth. And they said that, these results come from the World Wildlife Fund. No, only one number came from the World Wildlife Fund. So they've been trying to track down, where did this paragraph come from? Who wrote it? Who stuck in 5 mistakes in one paragraph, right? And they're still trying to track down exactly what happened. Apparently what happened was an internet report, not verified, not peer-reviewed. That's the source of some of this misinformation that came into one paragraph. So as a consequence, some people have called now for the removal of the chair of the Intergovernmental Panel on Climate Change. Because now we're talking about a factual mistake, not just jealousies and name-calling and turf mentality, but a real error in scientific judgment, putting in incorrect numbers, incorrect footnotes, incorrect conclusions. 5 mistakes in one paragraph. And so now people are saying, what else works in that 800-page document? Mm-hmm. So I don't think it changes the thrust of it. The Earth is heating up. Humans, you can see the fingerprints of humans all over the place. But it is embarrassing.
I'm like you. When all this broke, I read everything I could lay my hands on. I actually read the email. There's so many emails to read. It's ridiculous. And I couldn't find, as you point out, a smoking gun. It's not there. It's a big mess, and it's embarrassing, and it's a lot of things, but it doesn't mean that global warming is a lie. Quite to the contrary, anybody with eyes can look up north and see what's happening. We're getting a new ocean. And,
you can see the fingerprint everywhere. This decade, the decade that just ended, hottest decade recorded in the history of science. Mm-hmm. And we're looking at carbon dioxide levels. You have to go back a few 100,000 years to find comparable levels of carbon dioxide. So we're tampering with the Earth itself. And you look at temperatures. There's a spike just within the last 50, 100 years, and this spike is not normal. A spike in temperature. And so, the Earth does have cycles, as people have pointed out. It does have cycles. But if you take a look at the so-called current interglacial cycle, the last ice age was 10,000 years ago. Over that 10,000-year period, we have this spike taking place just in the last 50 to 100 years. Duh. I mean, maybe humans had a part to play in it.
Is there... can you look ahead, or can science look ahead and see where the point might be where it's irreversible, where, eventually it will be untenable for human life if a certain point is passed?
Yeah, I think there's not one point of no return. I think there's several points of no return. And one of them, I think, has already been passed. This is still controversial, of course. The North Pole. Some people say that no matter what we do now, the North Polar region will melt by the end of this century. No one has a crystal ball. No one knows for sure. But even if all the Kyoto protocols are put into effect now, then there's so much carbon dioxide in the atmosphere already that we're going to lose the North Pole. And, of course, our kids and grandkids are going to be angry at us. They'll say that Santa Claus comes from the North Pole, and the kids will say, look, I'm not stupid. Everybody knows there is no North Pole. It's all melted because you guys did nothing. So, our grandkids may accuse us of killing Santa Claus.
Mm-hmm. Boy, oh boy, oh boy. What does it mean if we have no more North Pole? Is there anything really serious that will impact the Earth with no more North Pole?
Yes. There's something called the thermohaline cycles. Benjamin Franklin was the first one to notice this. When Ben Franklin was going across the Atlantic on his numerous voyages, he noticed that there was a river underneath the oceans. And the river, as you know, extends from the Gulf of Mexico into Europe. And if you look at the map of the globe, England is comparable to parts of northern Canada. And I spoke in Moscow just a few months ago, and if you look at its latitude, it's way up north. So Europe, by rights, should be frozen solid. So why do we even have Moscow? Why do we even have England? And it's because of the Gulf Stream that comes from the Gulf of Mexico, goes across the Atlantic, as Benjamin Franklin first pointed out, and heats up, artificially in some sense, heats up Europe. As you know from the movie Day After Tomorrow that you spearheaded, if that thermohaline cycle is destroyed or disrupted or whatever, you're talking about a mini ice age gripping Europe. And we know that it's happened in the past. You can actually see the fingerprint of disruptions of the thermohaline cycle of the past. That's very dangerous if that happens.
Do you monitor the current measurements of the current? Are we beginning to see changes in that current already?
Well, what happens is fresh water is being dumped because Greenland is thawing out.
Right.
Greenland has lots of fresh water. It's being dumped into the North Atlantic, and it is already beginning to disrupt the Gulf Stream. It's not at a tipping point yet, so we shouldn't panic. But at some point, there could be a tipping point. Like I mentioned, I was just in Moscow speaking to the government there a few months ago, and they're complaining that Siberia is thawing out. That's why all these mammoths are being found that the Discovery Channel has specials about. How come all of a sudden all these ancient frozen mammoths and mammals and humans are coming out of the ice? And it's because the ice is receding. And as the ice recedes, it yields up humans and mammoths that have been frozen for thousands of years.
That's right.
So if Siberia thaws out, the tundra is going to thaw out, releasing methane gas. Methane, of course, is in your stove, but it's also decaying plant material creates methane. Methane is a worse greenhouse gas than carbon dioxide. So you have a vicious cycle. Heating causes methane to be released. Methane causes more global warming, more methane to be released, that could be a real tipping point. That's what people are really afraid of. If Siberia and Alaska thaw out, then we're in big trouble.
Alaska is thawing out. I mean, clearly it's thawing out.
Yeah, you can see housing tracts built on foundations of tundra that are sort of collapsing, roads collapsing in Alaska because the tundra is thawing out.
Well, they're already seeing some disruption in the current. Where it was strong, it's kind of fragmenting at times now. More and more often, it's fragmenting. It's not as strong as it was. It's really weird. So that could all... And another thing they're discovering is that some of these changes in the past that they thought occurred over very, very long periods of time, and it's one of the raps we took on the movie because we said it could occur so quickly with regard to the storm. These changes, they're now finding out through ice cores and the rest of it, occurred rather rapidly.
Yeah, that's kind of frightening. I had a chance actually to visit Iceland once. I gave a talk there, and they actually showed me the laboratory where these results were being done. They actually drill right into the ice of Greenland. They go many, many, many feet into the ice. They take out the ice. They look at the cores. And under a microscope, you can see like a zebra stripes, horizontal stripes. Some of them corresponding to volcanic eruptions that happened centuries ago. So you can actually date the various stripes in this long core of ice that's many feet long. It's about, 2 inches in diameter. You can actually date them because you know when certain volcanoes erupted. And when you do that, you find out that temperature swings take place not over just tens of thousands of years like we thought, but these swings can happen over a period of decades to maybe a century. Now, that's frightening, knowing that tipping points have taken place in the past and that a tipping point could happen in the future. So, of course, that's still speculation. But the past record is carved in ice. You can actually see it, tipping points in the past that have taken place over a matter of decades to centuries.
I've noticed the Discovery Channel has been making what I would call giving a disproportionate amount of time to different ways the world could end. They've got a lot of programs about asteroids hitting Earth and various different ways that all life could be simply wiped away from the Earth. Now, whether it's quickly, as an asteroid would, certainly accomplish, or it's a much slower process, one way or the other, eventually, if mankind is going to continue, we're going to have to figure a way to get off the planet and get elsewhere, aren't we?
That's right. And there's another worry to worry about on top of meteor impacts and the global warming. There's another thing to worry about, and that's solar flares from the sun. We used to think that the sun was pretty mild and not much happens, but we now realize on a scale of centuries, the sun has a temper tantrum. The last big solar flare was 1859. It's a Carrington event. Google it, and you'll be shocked what comes on your screen. In 1859, the sun went berserk. Astronomer was looking at the sun, noticed a solar flare, and about 8 minutes later, all of a sudden, telegraph wires were going berserk. All of a sudden, in Cuba, they could read the newspaper at night by the aurora borealis. When was the last time you saw the aurora borealis in Cuba? Telegraph wires went down, and messages were being sent even without electricity. There was so much electricity in the air that telegraph messages were being carried even though the telegraph itself was out. That's the Carrington event. That's when they didn't have satellites. They didn't have power stations. They didn't have refrigerators. If that Carrington event of 1859, 150 or so years ago, happened again, it could wipe out, first all satellites would get wiped out, then transformers would short-circuit on the Earth, power failures would take place, refrigerators would go out, all credit card systems would go out, and there's no rescue team because the rescue crew is also out. So you're talking about not one Katrina, you're talking about thousands of Katrinas around the Earth simultaneously. Food riots will start within a few days because people have no refrigerators, the food runs out. Business would come to a halt because credit cards cannot be done. Wall Street, of course, is paralyzed because there are no computers. You can't get on the Internet because satellites are out. no communications. We're so dependent on electricity. So we do have to worry about these things. Scientists have figured out that $2 trillion in property damage, modestly, could easily be that kind of damage could occur if there's another Carrington event.
Well, you've got to go back that far to look at the Carrington event. But, just a few years ago, as a ham operator, I monitor the sun all the time.
Mm-hmm.
And just a few years ago, we've now, as you point out, we've got satellites that monitor what the sun does. And there was an event, fortunately for Earth, this solar flare was not pointed in our direction, but it was so strong that the needles just pegged. In other words, the monitoring equipment wasn't even designed to measure a flare as large as we had. I can't recall the date of it. It was just a few years ago.
Right. In fact, our astronauts were actually told to go to a certain compartment of the space station where they have more shielding. Right. They were told to go there because they were in definite danger of being in the line of sight. What happened was a sunspot erupted, and a sunspot is like a rifle. It shoots a narrow beam of energy into outer space, and fortunately, as the sun was rotating and the Earth was moving, this gun barrel missed the Earth, okay? But it was so frightening that needles went off scale. We had to tell the astronauts to go to a certain secure compartment in the space station. We dodged the bullet that time, basically. But,
how big, I wonder if anybody knows how big that would have been had it hit Earth directly compared to, say, the Carrington event?
Well, it wouldn't have been as big as the Carrington event. We looked at ice cores, by the way. Going back with ice cores, the Carrington event actually affects ice. And you can actually see that maybe on a scale of centuries, you can have another Carrington event. But the event that you referred to just a few years ago was not on that scale. However, we are very young in the space age. We've had very few experiences with this. It happens, first of all, the solar flares erupt every 11 years. These are called the sunspot cycles. And it's when the North Pole and the South Pole of the sun flip. Believe it or not, the North Pole and the South Pole of the sun flip every 11 years. It alternates. Every time there's a flip, there's a shock wave emitted from the sun, and that's the solar flare. Right now, we're in a low cycle. The next flare-up will be, believe it or not, 2012. That's the next cycle. We're in a low cycle right now. Many people are
not
saying,
only low, Professor, but so weirdly low that most days the sun is blank. I mean, it's eerie what's going on right now. We've got a few of the new polarity sunspots up there that have rotated around. We've seen them, but there's very little going on. It's like the quiet before the storm.
Yeah, it is eerie. In fact, there are papers being published now among scientists saying, why? Why are we seeing very low sunspot activity? We haven't seen anything like this for quite a while. And we've been monitoring sunspots for over a century. Telescopes have been around for quite a while. We do monitor these sunspots. You have to go back a long time before you find this quiet activity like now.
All right. Anybody have any idea what's going on?
Well, right now, scientists are formally recommending that we reinforce our satellites so that they can withstand a blast of solar radiation, that power stations on the Earth be reinforced, cables be reinforced. But, of course, the politicians are doing nothing, right? But scientists are recommending that we reinforce our power stations and reinforce our satellites.
So there could be this could be the quiet before the storm.
It's possible. We actually know very little about sunspots. We've been monitoring them, for over a century, but we know very little about their activity. And we don't even know when the last Carrington event was before 1859. You have to go back to ice cores. And so one projection I saw said maybe once every 500 years. It's guesswork right now. We really don't know. We're putting darts on a dartboard.
Could there be a solar flare so big, Professor, that it would be an LA event?
Well, yeah, a catastrophic breakdown of modern society could take place very fast if there's another Carrington event. If that event of 1859 happened again, civilization is in real trouble.
And that's where we'll break right now. From Manila, in the Philippines, Southeast Asia, for George Norrie, I'm Art Bell. Seasons, nor the wind, nor the sun, none of them fear the reaper, but I guess we have to, at least for those who will come after us, and eventually we're going to have to find a new place to call home if we keep treating home the way we are right now. My guest is Professor Michio Kaku, and we're going to cover a little bit of time travel stuff, I think, in this next upcoming segment. So stay right where you are. Here's another fast blast that you can send off to me on coasttocoastam.com. Valdez from St. Thomas in the Virgin Islands asks, if a civilization in this universe should figure out virtually everything, how everything works, and reaches the absolute limit of knowledge, then what? Now, I realize you probably can't answer that, Professor, but it's an interesting question.
It's an interesting question because every time we mastered a force, history changed, human history changed. When Newton worked out the theory of gravity, mechanics came out, Newtonian mechanics, which allowed us to explain steam engines and locomotives, and that gave us the Industrial Revolution. So in some sense, the mastery of gravity and mechanics gave us the Industrial Revolution. And then Edison and Maxwell and Faraday worked out light and the electromagnetic force. And that gave us the Internet revolution, computers, lasers, electronics, all of that coming from the work of Edison, Faraday, and Maxwell. And then Einstein and others worked out the nuclear force, and that decoded the sun and gave us, commercial nuclear power and stuff like that. Now we're talking about a theory of everything. All forces, all the four fundamental forces, the light, gravity, the two nuclear forces, all four fundamental forces worked out. Now, again, matter is not stable at the energies we're talking about with the Large Hadron Collider. So no bomb is going to be coming out of the unified field theory. But in the future now we're talking centuries, a millennium of the future,
right?
Perhaps those civilizations can really use the theory of everything to answer questions about time travel, warp drive, wormholes, multiverse, higher dimensions, hyperspace. These are all things that we just talk about today, but we need a theory. We have the theory. It's called string theory. But we can't use it. You can't play with it. You can't manipulate it because, we're too primitive. But in the future, as time goes by, if you are a master of all four fundamental forces, then you would have near godlike powers. You'd be able to answer the questions about space and time that are almost science fiction.
If we ever achieve that, I wonder if we'll be ethically and morally prepared for it.
Well, if it happened now, I think we are woefully unprepared.
Right.
We still have all the savagery of a Type 0 civilization emerging from the swamp. And, we're talking about Type 3 technology, galactic technology we're talking about. And, as I mentioned, we physicists have thought about maybe these civilizations already exist in outer space. Carl Sagan used to wonder, is there a nearby Type 3 civilization? If there is, would we be smart enough to even know it? And the answer he came up with is rather depressing. He said, no, we are so primitive that even if there is a nearby Type 3 civilization, we're too primitive to even know our next-door neighbor. That's how primitive we are.
All right. Quickly, there is something, before we get to time travel, I want to go there. By the way, I've got a great guest coming up Sunday on time travel, Dr. David Anderson. But right now, I want to talk for a second about invisibility. There's been a lot of progress, I guess.
Right, huge progress.
What's going on?
Well, first of all, we took a camera crew all the way down to Duke University, where the first invisibility experiments were successfully done on microwave radiation. We also went to Berkeley, where they're now showing that in principle light can also bend in these bizarre ways. And for me, it's a little bit embarrassing because sometimes I teach optics, and I used to teach the students that invisibility is impossible.
Right.
Unlike water, a light cannot wrap around an object and reform at the other end like water does when it goes past the boulder. Light cannot do that. It violates the laws of optics. Well, I was wrong. And so was every single physics textbook on the planet Earth. Now we do it. We filmed it. Again, with microwave radiation, you can actually show that microwaves, like water, will wrap around an object, reform at the other end, if you use something called metamaterials. And at Berkeley, they've even done it on a small scale with visible light. And guess who's funding it? The Pentagon, they're not stupid. I mean, think of the advantage if your soldiers and tanks are invisible. True, not stealth. We're not talking stealth. We're talking true invisibility. We don't have it yet, but again, the basic foundation is being laid even as we speak.
True, let me ask, true invisibility as in from any angle?
That's right. As in Harry Potter. Think of the invisibility cloak. Again, we don't have it yet. The Pentagon is pouring money into this. This is a very hot topic. Many of my friends are dropping their research and going into this area. There are many obstacles that we have to cross. For example, inside the cloak, you cannot look outside. Inside the cloak, you're blind, basically. You have to drill 2 holes. So from the outside, people see 2 floating eyeballs, which are your 2 cutaways in your invisibility cloak.
Can you give me a pedestrian idea of how this is done? I can imagine invisibility straight on. I can't imagine how it would be achieved at true invisibility at any angle, just gone.
Yeah, well, here's how it works. In every single optics book on the planet Earth, we always assume that substances are clear and uniform, like water, oil, diamonds. Scientists used to spend whole careers measuring the properties of diamonds and oil and water as light traveled through them. We always assumed they were uniform. But if you drop that assumption and put impurities, tiny little impurities smaller than the wavelength of light, let's say, these impurities can kick the light beam in different ways, push it, nudge it in ways that are usually thought to be impossible. So with microwaves, we've done it, okay? It's been done. It's been photographed. We did it for our science special on Sci-Fi Science, again, on the Science Channel every Tuesday at 10 o'clock. We filmed it. You can actually see that microwaves are being kicked in the wrong direction. Now, if we could do that for light, then we're in business. Then, instead of a stealth bomber, we're talking about an invisible bomber, an invisible soldier. Again, this is the Pentagon is taking this very seriously. They're the ones funding it.
Well, what? I'm trying to imagine for a soldier, for example, a person. How would this be achieved? Would he carry a mechanism with him?
It would be a cloak of some sort, in the sense that you want light to wrap around the object, reform like water on the other side. If you're downstream from a boulder, you don't know that there's a boulder upstream because water has wrapped around the boulder, reformed, and you see the water as if there is no boulder upstream. You can't detect the presence of the boulder. Now, we used to say that light cannot do that, and there's a simple theorem in optics showing that you cannot do this. But now we show that if that boulder is made out of irregular material, impurities are embedded into it, tiny little impurities. These impurities can kick the light beam so that light wraps around an object. So Harry Potter would put on this cloak, light hits the cloak, wraps around the cloak, reforms behind him, and you see no Harry Potter. He is literally invisible. And in fact, that answers one of the questions that Stephen Hawking, my colleague, used to say. He used to say, if there are time travelers, why don't we see them? Where are the time travelers from the future, the tourists from the future? Maybe they're invisible.
If that was achieved, just for the sake of a question that I'm wondering about, the mass would still be there. In other words, the invisible person could still bump into somebody, couldn't they?
Yeah, the way you get around the invisible soldier is to throw sand on top of him. Just like in the Hollywood movies. If you throw sand on top of the invisible man, then you could see the outline of the invisible man.
Or as in the movie Rain, even Rain.
Yeah, so the Pentagon is looking at invisible airplanes, invisible tanks, where if you have an airplane that is truly invisible, you can't fire at it. Radar won't pick it up because it has stealth, and you can't even see it optically. You can see a stealth bomber. It's staring right in front of you. But radar is dispersed as it bounces off the stealth bomber, and that's why a stealth bomber has a radar image of the size of a large bird, okay? So radar can just barely pick out the presence of a stealth bomber. But visually, you can see it as night, like it's just staring at you. But now we're talking about something that's genuinely invisible.
I guess in a way it's a shame that so much science has direct military-industrial complex application.
Yeah, it's sad. A lot of technology was pushed during World War I and World War II because they were wars. A lot of technology was pushed through. And even things like celestial mechanics, working out the motion of the planets, Napoleon's scientists did a lot of that. And why did Napoleon endow all his scientists' time to work on the motion of the planets? Because he also wanted to know the motion of cannonballs. Mm-hmm. He also wanted to know where the cannonballs would land on the British and stuff like that. So Newton's laws, which govern the heavens, were also used by Napoleon scientists to conquer Europe. So it's sad, but that's the way it's been for centuries, that the engine behind a lot of these discoveries is the military.
So somewhere behind the scenes, or not so far behind the scenes right now, a lot of work is going on with regard to invisibility.
Yeah. However, it's still at the beginning stages. You know, the big breakthrough was only made 2-3 years ago. So it's a very young science, and still a lot of hurdles to be made. The biggest hurdle is to make the transition from microwaves to visible light. Several groups, Caltech, Berkeley, and Karlsruhe in Germany, have shown that visible light will also bend in this bizarre way, but they've only done it on a microscopic scale. In principle, they can make a bacteria invisible. That's not very practical. We have to expand it to a large size, and they haven't done that yet. So we have a long ways to go before we have true invisibility, but it's not out of the question anymore. In our lifetimes, it could definitely happen. Not tomorrow, but yeah, in the coming years, decades, we could definitely get closer and closer to the Harry Potter invisibility cloak.
Gosh, Professor, in the years that you and I have been doing interviews, so much has gone from ha, 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 to here we are, or here we will shortly be.
Mm-hmm. Isn't it amazing, right? It's moving that fast.
What about time travel?
Well, time travel is still, again, in the far future. We're talking about being able to play with time itself. But there are reputable physicists working on time machines. In fact, we took a film crew to Princeton to film some of the physicists there who have blueprints for what a time machine would look like.
Oh.
Now, of course, you cannot build one in your basement. Don't believe it if someone announces that they built a time machine in their basement. Again, we're talking about harvesting enormous amounts of matter, either negative energy or negative matter and positive matter. In Star Trek, the latest movie, they used the black hole as a way to go backwards in time. Mm-hmm. That's actually conceivably possible. You would have to, of course, protect yourself as you went through the black hole. But there are theories. Cosmic strings, black holes, rotating universes. There's several proposals for how to build time machines. But again, all of them require vast amounts of matter and energy.
Well, again, if it's ever going to be done, then it's already been done in the future. And the old question of where are they? Well, maybe they're invisible, but they'd be at least bumping into us. We'd have some clue, I suppose, that they are here, and they should have been here by now.
Well, my attitude is that if you go backwards in time and visit the dinosaurs, after a while you get a little bored. I mean, if you see some dinosaurs fight once, you're not thrilled the second, third, fifth, 10th time. So you're not going to want to go back to see the dinosaurs all the time. And maybe we're not very interesting to our descendants. Maybe our descendants would say, "Oh my God, back then in the 21st century, Stone Age. I mean, who wants to go back there again for the 10th time?"
I've seen a lot of good dinosaur fights on Discovery anyway.
Mm-hmm, right. And so I imagine that we're just not interesting enough. However, if somebody knocks on your door and claims to be your great-great-great-great-great-granddaughter, don't slam the door.
Oh,
maybe your descendants want to meet the great Art Bell.
Would the... If time travel is possible, would all the old laws that we think apply? In other words, killing your grandfather, all that sort of thing, or would it simply not be possible, in your opinion, to do a paradox, to make a paradox?
Well, there are two ways to handle the paradox problem. Okay. The Russians are pushing one way, and that is if you go backwards in the past, you want to kill your parents before you're born. Maybe there's something preventing you from pulling the trigger. Like, for example, you cannot walk on the ceiling. Why can't you walk on the ceiling? Because we have a law, the law of gravity. Maybe there's a law of causality that prevents you from pulling the trigger. Well, I find that hard to believe, that free will would be influenced by a time machine. I think the way out of it is an alternate reality opens up. Einstein said that time is a river. Einstein talked about the meandering river of time. But the new wrinkle is that the river of time may fork into two rivers or have whirlpools. That's causing all the excitement. Many papers now are being written on these whirlpools in the fabric of space and time. And maybe the river of time splits. If you watch the latest Star Trek movie, they say it explicitly that the time stream forks off into a different direction, an alternate reality, they said in the Star Trek movie. That's the way to resolve all the paradoxes without having any problems, because when you kill your parents before you're born, you kill somebody else's parents who's genetically identical to your parents.
Uh-huh.
Your parents lived to give birth to you. You can't change that. But you can change somebody else's past. You can save somebody else's Abraham Lincoln from being assassinated at the Ford Theater. But you can't change your own Abraham Lincoln. Your own past is fixed.
By the way, just as a matter of curiosity, when they're getting ready to do a new Star Trek movie, or, I don't know, perhaps one of the great movies that we've just watched, do they come to people like you and ask, well, look, what can we speculate about?
Yes, they do. In fact, I'll be interviewed by William Shatner for a coming Discovery Channel program, and you can actually submit plots yourself. A certain fraction of the Star Trek movies are based on audience writing proposals and sending in to Paramount Studios and having the scriptwriters incorporate these ideas. And there's even a guy that I was talked to who writes the technobabble that Data says and that these people mention.
Mm-hmm.
A lot of the technobabble is actually real, and I actually had a chance to meet the guy who writes it. And wow. I was wondering, where did all this technobabble come from? It does make some sense. And I realized there's a physicist who actually writes that technobabble.
Well, actually, when you watch Avatar, you realize that, I mean, you're in a whole different world, and a different world that makes sense.
And some of the technology in that movie is not totally out of the question. Like, the fact that you can put your mind into a clone. We can actually connect our mind to a robot now. This was done just a few months ago by the Honda Corporation, in fact. The Honda Corporation has a robot called Asimo. Very advanced. It could walk, it can run, climb stairs. It dances better than me. I've had a chance to interact with Asimo several times for BBC television. Mm-hmm. And you can now put a helmet on, which measures your EEG signals, your brain waves, communicates that electronically to Asimo, and you can actually move the robot by thinking. By simply thinking, you can make 4 movements of the robot: left arm, right arm, and head movement, left, right. You can actually make 4 independent movements. Now, replace that robot with an avatar. And then you begin to realize it's not totally out of the question that we would be able to use our brain waves to control a robot. The robot then controls a clone. If you saw the movie with Bruce Willis, Surrogates, that's exactly what they did in that movie, Surrogates. You are in a chamber. Your thoughts are connected to a robot. The robot is perfect, beautiful, handsome, super strong, and you are sitting in a pod, but you live your life through a surrogate. That's the movie Surrogates.
Right.
Right. That could be coming, again, relatively soon. We already can do it at the level of 4 motions of a robot. But what's to prevent us from, full-bodied motion?
I suppose once we can, in effect, transfer a brain, then we achieve some sort of immortality.
Yeah.
Professor, hold that thought. We're, again, at a break point, and we will, in this next hour, get the phone lines open, so warm up your phones, folks, and get ready. From the other side of the world, from the majority of you anyway, I'm Art Bell for George Norrie from Manila,